Good day, everyone. So today we will be studying a subtopic of pre-calculus, which is analytic geometry. So analytic geometry is a branch of algebra that deals with modeling of some geometrical objects. Under analytic geometry, we have what we call conic sections. Now, a conic section is formed from the intersection of a plane and a cone. And the first of our four types of conic sections is circle. So what we know about circles is that it does not have an infinite number of sides, and all of its arc has equal distance to its center. Circles can be represented with a standard equation of x minus h squared plus y minus k squared is equal to r squared. This is when its center is not located at the origin. But if it is, then we can represent it as x squared plus y squared equals r squared. And by general equation, it is x squared plus y squared plus ax plus by plus c is equal to 0. So, hk in this equation translates to its center. Let's try a simple problem. So for example number 1, we have x minus 3 squared plus y plus 9 squared equals 2021. So let's try to find the center and the radius. Looking at our equation and looking at the standard equation of circles, we can already tell the answer. So since our center is our hk, that means our h is 3 and our k is negative 9. Why? Because in the standard equation, it is written as x minus h and y minus k, meaning that it's supposed to be the opposite of the integer. Plus, our radius would be the square root of 2021, since in our standard equation, we have r squared. Let's move on to our example number 2. So here we are given the center, which is 3, 2, and a point, which is 1, 2. So let's assume that the point is part of the arc or the circumference. So then we just have to substitute it to the standard equation. So we already know that our center is the hk, and the point is actually interpreted as our xy. So we just have to substitute it to our standard equation, and that will result to, open parenthesis, 1 minus 3 squared plus 2 minus 2 squared equals r squared. So we will have 4 plus 0 is equal to r squared, and our answer would be 2, since we are measuring distance. So, since we are talking about the distance, we shouldn't forget about the unit. But since the given did not give a specific unit to use, we'll just put 2 units. Okay, so let's try a harder problem. So, for example number 3, you have 3 givens. So we have point 1, which is 5 and negative 1, point 2, which is negative 3 and negative 1, and lastly, point 3, which is 3 and negative 7. So how do we solve this? First, we have to substitute it individually to the standard equation. So, for equation number 1, let's try and substitute 5 and negative 1 to our x and y, since it is a point. So we have 5 minus h squared plus negative 1 minus k squared equals r squared. And once we simplify that, we'll have 25 minus 10h plus h squared plus 1 plus 2k plus k squared is equal to r squared. So we will have k squared plus h squared plus 2k minus 10h plus 26 minus r squared equals 0. And for our next equation, equation number 2, we'll substitute negative 3 and negative 1. So we'll have negative 3 minus h squared plus negative 1 minus k squared equals r squared, which will result into 9 plus 6h plus h squared plus 1 plus 2k plus k squared equals r squared. And it will also result to h squared plus k squared plus 6h plus 2k plus 10 minus r squared equals 0. So right now, all of this might seem a little hard and challenging, and it actually takes a lot of time to do, but later it will all make sense. So let's move on to equation number 3. So we have 3 and negative 7. So we will have 3 minus h squared plus negative 7 minus k squared equals r squared. So we will have 9 minus 6h plus h squared plus 49 plus 14k plus k squared equals r squared. And it will become h squared plus k squared minus 6h minus 14k plus 58 minus r squared is equal to 0. Now, this is where the real challenge and satisfaction will result. So, let's subtract, or we will use elimination method, and we will subtract equation 2 to equation 3. So we have h squared plus k squared plus 6h plus 2k plus 10 minus r squared is equal to 0 minus parenthesis h squared plus k squared minus 6h plus 14k plus 58 minus r squared equals 0. So once we simplify everything, it will result to 12h minus 12k minus 48 equals 0. So we use elimination method to eliminate variables that are hard to simplify. So we will repeat the same process with equation 1 and equation 2 so that we can find the value of h. So we have h squared plus k squared plus 2k minus 10h plus 26 minus r squared equals 0 minus h squared plus k squared plus 2k plus 6h plus 10 minus r squared equals 0. So we will have 16h plus 16 equals 0. So this is actually very hard, but once you master the FOIL method, it is actually quite easy. And there are other methods that we can use in binomials. So this is where everything comes together. So since we have the equation negative 16h plus 16 equals 0, we just have to simplify it. So we have 16h equals to 16. And if we divide both sides by 16, we will have h equals 1. So we can use that in the fourth equation, which is 12h minus 12k minus 48 equals 0, to find the value of k. So we have negative 12k equals 48 minus 12 times 1. Then negative 12k is equal to 36. We just have to divide it by negative 12. Now we have k, which is negative 3. And then for our radius, we just have to substitute it to one equation. So we will use the first equation. So we have 5 minus h squared plus negative 1 minus k squared equals r squared. So if we substitute h and k, we have 5 minus 1 squared plus negative 1 plus 3 squared equals r squared. We have 16 plus 4 equals r squared. So if we square root r, or r squared, we have 4.4. Finally, we can assemble our standard equation since we have our r squared and hk values. So we have x minus 1 squared plus y plus 3 squared equals 20. So our next conic section is parabola. So parabolas are a set of all points in a plane that are equidistant from a fixed line and a fixed point that is not on the line. So when we talk about the fixed line, this is the directrix, and the fixed point is the focus. So we have different parts of the parabola. So we must always remember that our P is the distance between the directrix to the vertex, and it is also equal to the distance of the focus to the vertex. Our standard equation of the parabola is x minus h squared equals 4p times y minus k, and x minus h squared equals negative 4p times y minus k. So the first standard equation is when our parabola is opening upward, like the image presented. And the second equation represents a parabola that is facing downwards. So when we have a parabola that has y minus k squared, that means this is either opening to the right or to the left. We can always identify that with the integer or the sign of our 4p. So when it is negative 4p and it is y minus k squared, then it is facing or opening to the left. And if it is positive, then it is opening to the right. We then have our general equation, which is x squared plus by plus f equals 0, and y squared plus dx plus f equals 0. So let's try an example. For example number 1, we have a vertex of 2 and 1 and a directrix of x equals 5. So like we said a while ago, we have what we call P, which is the distance of the directrix to the vertex, and it is also equal to the distance of the focus to the vertex. So let's try to find the focus and the general, or rather the standard equation. So in order to find our P, it's either we have to graph it or we can just use simple rules. So we have to subtract 5, which is our directrix, and 2. So why? Since our directrix is x, this means that our graph, or our parabola rather, is facing left or right, since it is vertical. So we have to subtract 5 to our x value, which is 2, in order to get the distance, which is P is equal to 3. After finding our P, we can then find our focus. So our focus is 2, which is our x for our vertex, minus our P, which is 3. Then we have 1 as our y, since it lies on the axis of symmetry. So then we have our focus, which is 1, 1. So how do we know if it's really facing to the left or to the right? So we already know that our focus and our vertex is on the right side of our directrix. That is how we can identify if it is facing either left or right. And it is also applicable in horizontal or up and down facing parabolas. So if we try to form our standard equation, we would have y minus 1, which is our k squared, equals negative 4p, because it is facing to the left, times x minus 2. It's a little complicated at first, but once you understand the concept behind how parabolas work, then it's actually quite easy. My way of indicating if it is up, down, or left or right is if which variable is squared. Because when it is squared, this indicates that there are two values of a variable to another variable. So in this problem, we have two values of y in a x value. So next, for example number 2, we have a vertex of -4 and 3 and a point of 0 and -1, assuming that there is a vertical axis. So we just have to substitute our point and our vertex since it is xy and hk. So now we have 0 plus 4 squared equals -4p times -1 minus 3. So if we simplify that, we will get the value of our p. So we have 16 equals -4p times -4, which is 16 equals 16p. And if we divide both sides by 16, we would get p is equal to 1. So like I said before, we just need to add our p, or we just need to subtract and add our p to find the directrix and the y or x value of our focus. So for our directrix, we just need to add 1 to our k, which is 3. So we have d is equal to y is equal to 4. And for our focus, we just need to subtract 1. So we have f is equal to -4 and 2. Before we move on, let's try to analyze first how it became, or how the parabola faced downwards. Well, this is because our vertex, which is -4, 3, is located above our point, which is 0 and -1. Then, it states that it is vertical axis. So from the first two given, it already says that it is either facing downward or to the right, since our point is on the right side of the vertex. But since it says that there is a vertical axis, which is our directrix, then that means that it is facing downwards. So moving on to our third conic section, which is our ellipse. So when we talk about ellipse, this is usually an oval shape. So it can be in horizontal or vertical. So the standard equation for our ellipse is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So this is when it is horizontal. So an example of a horizontal ellipse is like the image presented. So we can always determine if it is horizontal or vertical, which partners which. So if our A is located underneath X, then that means it is horizontal. And if it is located under Y, then that means that it is vertical. Now for our general equation, we have ax squared plus cy squared plus dx plus ey plus f is equal to 0. So we actually have many different parts for our ellipse. So we have A. So this is the distance between the center and the vertex. So we also have B, which is the distance between the center and the co-vertex. And D, which is the distance between directrix and center. And we have E, which is eccentricity. So this states how round a shape is. So we have E, which is the latera recta, the F, which is the focus, the V, the vertex, the W, the co-vertex. So we also have the minor and the major axis. So the major axis is the longest axis, which is 2A, and the minor axis is 2B. So our co-vertex is always located in the ends of the minor axis, and our vertex is located at the end of the major axis. And in order to solve for c, we have c squared is equal to a squared minus b squared. And for our d, we have a over e. And for our e, it's either c over a or a over d. And for our latera recta, we have h plus c and b squared over a. And this can also vary since we have 4 latera recta points. So for our example number 1, we have the center of 2 and negative 3. So we have vertex 1, which is 7, negative 3, vertex 2, which is negative 3 and negative 3, and an eccentricity of 3 over 5. So we can already tell that our A is 5, our C is 3. How? Since if we graph it from our center to our V1, we just have to subtract 7 and 2. So it will result to 5. And for our B, we have to solve it by using b squared is equal to a squared minus c squared. So this just rooted from our formula a while ago. So if we substitute it, we have b squared equals 5 squared minus 3 squared, which is 4. And for our d, we just have to use our value from a and our value from the eccentricity. So we have 5 over 3 over 5. So we just have to inverse 3 over 5 and multiply it to 5. So we have 25 over 3 or 8.33. So if we plot all of the findings, we can arrive to F1, which is 5 and 3. So this can also be solved because if we add 3 to our center, it will result to 5. So we have 5, 3. And if we subtract it, we will get our F2, which is negative 1 and negative 3. Since C is the distance between the center and the focus. And for our co-vertex, we just need to add and subtract our value of B. So we will have W1 is 2, 1, and W2 is 2 and negative 7. So if we assemble it all together, we will have a standard equation of x minus 2 squared over 25 plus y minus 3 squared over 16 is equal to 1. It must always equal to 1, and the sign between the fractions must always be in addition or positive. And in order to get our 25 and 16, we just have to square our a and our b. So let's talk about the hyperbola another time. So thank you for watching.